Good morning to all. Now we are going to learn about computer architecture. So these are all the topics in Unit 1. Unit 1 is a basic structure of a computer system. So in this unit, we are going to discuss about the functional units, basic operational concepts, performance and the languages being used in a computer, operations and operands, and the logical operations, decision making, MIPS addressing. So these are all the concepts we are going to discuss in the upcoming topics. First of all, the computer architecture is a set of rules and the method that describes the functionality and the organization to implement the computer systems. So the 8 ideas of a computer architecture is Moore's law, abstraction to simplify the designs, common case fast, performance via parallelism, performance via pipelining, performance via prediction, hierarchical memory, dependencies via redundancy. The Moore's law state that the integrated circuit resources doubles every second, years or a month. So the evaluation be in a gradual level. Abstraction to simplify the design. Abstraction means both the computer architect and the programmers had to invest the techniques to make themselves more productive, for otherwise design time would lengthen as dynamically as resources grow by the Moore's law. Common case fast means making the common case fast will tend to enhance the performance better than optimizing the rare cases. More number of trial and error will be present while designing the processor in case if any particular design is not supported for that configuration, it is better to change the design or to change the entire architect for the processor. Performance via parallelism. Throughput will be increased when using a parallel architecture for execution of multiple tasks. Performance via pipelining. Pipelining is used to fetch the instruction for execution in parallel. Operations of pipelines are first instruction output may be taken as an input of next instruction for processing. Performance via prediction. In some cases, it is required to use the predicted processing instead of accurate. Hierarchy of memory. The programmers want a memory to be a fast, large and cheap, as memory speed often shapes performance. Capacity limit the size of problems that can be solved. The cost of memory today is often the majority of a computer cost. So this is a hierarchical representation. The bottom layer is a magnetic tape followed by the hard disk. After that a main memory, then cache, and the topmost layer is under registers. Dependencies via redundancy. The computer only need to be a fast, they need to be dependent since they are physical devices can become system dependent by including the redundant computer that can take over when a failure occur and to help the detection of failures. The components of computer systems are input unit, output unit, ALU unit, control units and output unit. So this is a diagrammatic representation of an computer architecture. So this is an internal part of an CPU which consists of CPU, RAM, motherboard, hard disk, fan, CD-ROM. So these are all the physical parts which are all presented in the CPU. The softwares are system software and application software. System software acts as an intermediate between the user and computer hardware. Through this, we can create, modify the source programs and codes. Application softwares are word processor, spreadsheets, image editor, and DBMS. These concepts are called it as application levels. Next, the vacuum tubes. The vacuum tubes are the initial generations of a computer that can be used to perform a more computation. It can perform a 5000 additions and subtractions per second. So this is a diagrammatic representation. Next is a transistor is a smaller than the other devices, consume a less power, which will operate in a high speed, more memory space, and the size of the transistor is small. So this is a transistor diagram. Integrated circuits. The integrated circuits are being developed in a previous generation which allows the increases memory size, more number of input and output ports. It will provide the maximum number of port compared with other generations. So this is integrated circuit, ICs. VLSI concepts is a very large scale integrated circuit uses LSI and VLSI for a computer design. It is possible to manufacture the entire CPU's main memory into a single ICs. The performance are being evaluated with the help of the formula that is 1 divided by execution time. The execution time is also referred as the response time. The reduction in a response time is increases the throughput. If the performances of two devices and the execution of two devices are being evaluated with the help of the following formula, performance of A divided by performance of B equal to execution time of B divided by execution time of A. The performance metric, the overall CPU performance calculated using this formula, CPU clock cycle for a program divided by clock rate. Power walls. Running a processor in a high clock speed allowed to perform a better performance, but when you compare with a high supply, it generated a more heats. How the problem is addressed? By lowering the power supply voltage as possible to reduces the power consumption. The basic operational concepts are the computer to execute a program and the sequence of instructions are being stored in a computer memory. The instructions are executed to process the data which is located into a computer memory through the input unit. After processing the data, the result is stored either in a computer memory for their future reference, and output will be displayed through the output ports. The connection between the processor and the main memory is at the bottom of the layer is on a main memory which is connected with the MDR, MAR and the control units. The special functional registers are program counter, instruction register, memory access register, memory data register and memory buffer registers. Instructions. The number of operation and instructions are executed based on the CPU, which means that the CPU can be represented as a machine instruction. Machine instructions are in a form of a binary codes. Elements of instruction. Operation code, source and destination operand, source operand, destination operand, next instruction address. So the instructions are being represented in the following format. First one is opcode followed by the operand address 1 and operand address 2. Instruction type. According to the operation that can be categorized into arithmetic and logical instruction, memory instruction, data transfer instruction, test and branch instructions. The types of operands. Each instruction in a program specify the operation to be performed and the data to be processed. So the instructions are divided into opcode and operands. Types of operations are data transfer operation, move, store, load, exchange, clear, set, push and pop operation. So these are all the arithmetic operation. Arithmetic and logical operation, add, subtract, increment, decrement. So these are all the logical operations, and, or, not, or. Instruction format. The instructions are being represented with the help of address range and address gratitude. The advantages of specifying the addresses are flexible and reduces the count of instruction and reduces the amount of space. The types of addressing modes are register addressing, direct or absolute addressing, immediate addressing, indirect addressing, displacement addressing. Have a 3 types: relative, base register addressing, index addressing, auto increment and decrement, stack addressing. Immediate addressing means the operand is implicitly specified in the instruction itself. Indirect in the sense the address of the memory which will be refer the address of the operand. So the address is not implicitly specified in an instruction. You need to refer a memory location. Register indirect means the register address or indirectly specified in an instruction. Displacement address, you needed to calculate the effective address with the help of value plus address of the register. Relative addressing mode refer a program counter, hence it can be used by representing the program counter relative addressing. The PC addresses are added with an effective address. Base register addressing consists of both the main memory allocation address as well as the displacement address. the index addressing or a main memory address and the reference register address. Stack registers which can perform the push operation as well as the pop operation. Thank you.